A curious boy who failed many early exams grows into the scientist who redefines the universe. The story follows Einstein's struggles, his thought experiments, and the moment he discovers the theory of relativity. In the late 19th century, in the German city of Ulm, a child was born who was slow to speak. His parents worried. His teachers despaired. They saw a quiet, daydreaming boy, one who resisted the rote learning and the rigid discipline of the German school system. They called him lazy, undisciplined, a potential failure. This boy, Albert Einstein, was not a failure. He was simply listening to a different rhythm, the silent hum of the cosmos that only he could hear. His mind was not in the classroom memorizing dates and the facts. It was soaring through space, chasing beams of light. This was not the story of a born genius who effortlessly excelled, but of a persistent, imaginative mind that had to carve its own path against a mountain of doubt and convention. His journey was one of rebellion against intellectual authority, a testament to the power of curiosity over conformity. From a young age, Einstein was captivated by the unseen forces that govern the world. A compass, given to him by his father when he was just 5 years old, became his first great mystery. Why did the needle always point north, trembling with an invisible, unwavering purpose? This simple thought ignited a lifelong fascination with the fundamental laws of nature. While his peers played games, Albert constructed elaborate houses of cards, some towering 14 stories high, a display of the patience and the precision that would later define his scientific endeavors. He found solace not in the rigid curriculum of his school, but in the books his family friend, Max Telmy, brought him. He devoured works on science, mathematics, and philosophy, teaching himself Euclidean geometry at the age of 12. The logical certainty of mathematics felt like a revelation, a pure language that could describe the very structure of reality. These early experiences nurtured a deep-seated belief that the universe was, at its core, simple and understandable, a puzzle waiting to be solved. However, the world of formal education remained a constant source of friction. Einstein's rebellious spirit clashed with the authoritarian nature of his teachers. He famously dropped out of his high school in Munich, finding the atmosphere stifling to his creativity. His attempt to enter the prestigious Swiss Federal Polytechnic in Zurich directly was met with failure. He passed the mathematics and the physics sections with flying colors but failed the general subjects of botany, zoology, and the languages. It was a humbling setback, forcing him to attend a cantonal school in Aarau, Switzerland, to complete his secondary education. Yet, this perceived detour proved to be a blessing. The liberal, progressive environment at Aarau encouraged visual and intuitive thinking, a method that perfectly suited Einstein's imaginative mind. It was here, at the age of 16, that he conducted his first great thought experiment, a mental exercise that would set the stage for his revolutionary work. He asked himself a deceptively simple question: what would the universe look like if he could ride alongside a beam of light? Upon finally graduating from the Zurich Polytechnic in 1900, Einstein found himself an outcast once more. His professors, irritated by his tendency to skip lectures in favor of studying on his own, refused to write him letters of recommendation. The brilliant graduate, the man who would one day be synonymous with genius, was unemployed and seemingly unemployable in the academic world. For 2 long years, he drifted, taking on odd tutoring jobs and struggling to make ends meet. Desperation led him to a modest position at the Swiss Patent Office in Bern. To men, this would have seemed like the end of a dream, a descent into bureaucratic obscurity. But for Einstein, the patent office became his sanctuary. The work was undemanding, requiring him to analyze the mechanics of inventions, a task that sharpened his ability to dissect complex problems. With his daily duties finished in a few hours, he was left with a desk, a quiet space, and the precious time. Time to think. Time to let his mind wander back to the question that had haunted him since he was a teenager: the nature of light. The year 1905 would forever be known as Einstein's Annus Mirabilis, his miracle year. Working in relative isolation, the 26-year-old patent clerk produced 4 groundbreaking papers that would irrevocably alter the course of physics. He proved the existence of atoms by analyzing Brownian motion, introduced the concept of the photon in his work on the photoelectric effect for which he would later win the Nobel Prize, and he laid down the foundations of spatial relativity. It was in his paper on the electrodynamics of moving bodies that he tackled the paradox of reading a light beam. The prevailing physics of the time, rooted in the work of Isaac Newton and James Clerk Maxwell, presented a contradiction. Maxwell's equations dictated that the speed of light in a vacuum is constant, regardless of the motion of the source or the observer, but Newtonian mechanics suggested that speeds should be relative. If you chased after a light beam, it should appear to slow down. Einstein's solution was both audacious and elegant. He proposed that it was not the speed of light that was relative, but space and time themselves. He imagined a train moving at a constant speed. If a bolt of lightning strikes both ends of the train simultaneously, an observer standing on the platform midway between the 2 strikes would see them as happening at the same time. However, for an observer on the moving train, the light from the strike at the front of the train has to travel a shorter distance to reach them, so they would see it first. Two events that were simultaneous for one observer were not simultaneous for another. Time, the steady, universal clock that Newton had envisioned, was not absolute. It could stretch and shrink depending on one's motion. This led to the mind-bending conclusion that time slows down for a moving object relative to a stationary one. From this single principle, he derived the most famous equation in history, AMC-MC. This simple statement revealed a profound and terrifying truth, that mass and the energy are two sides of the same coin, and that a tiny amount of matter could be converted into a tremendous burst of energy. The publication of these papers did not bring immediate fame. The scientific community was slow to grasp the radical implications of his work. But one influential physicist, Max Planck, recognized the genius within and championed his ideas. Slowly, Einstein's star began to rise. He was finally offered a position as a professor, first in Zurich, then Prague, and finally in Berlin, the epicenter of the physics world. But his work was far from over. Special relativity dealt with constant, uniform motion. What about acceleration? What about gravity? For the next decade, Einstein wrestled with this even greater challenge. He called it the happiest thought of my life, the realization that an observer in a free-falling elevator would feel no more gravity. They would be weightless. From this, he deduced the principle of equivalence, that the effects of gravity are indistinguishable from the effects of acceleration. This was the key he needed. He embarked on a grueling intellectual marathon, navigating the complex mathematics of non-Euclidean geometry with the help of his friend, Marcel Grossman. He imagined space and time not as a passive stage for the events of the universe, but as an active participant of flexible, four-dimensional fabric he called space-time. Massive objects, like the Sun, do not exert a mysterious force of gravity on planets like us. Instead, they create a deep curve, a warp in the fabric of space-time. Planets are not being pulled. They are simply following the straightest possible path through this curved geometry. It was a complete reimagining of the universe. After years of false starts, dead ends, and the intense mental exertion that brought him to the brink of physical collapse, he finally completed his masterpiece in November tahun 1915, the general theory of relativity. The theory was a stunning intellectual achievement, but it needed proof. Einstein predicted that the immense gravity of the Sun would bend the light from distant stars as it passed by. The effect would be too small to see, except during a total solar eclipse. The outbreak of World War I delayed any attempts to verify his claim. But in 1919, British astronomer Arthur Eddington led an expedition to the island of Principe off the coast of Africa to observe a solar eclipse. As the moon blotted out the Sun, the team photographed the stars near its edge. When the photographic plates were developed and compared to images of the same star field taken months earlier, the results were undeniable. The stars' positions had shifted, bent by the Sun's gravity, by the exact amount Einstein had predicted. The news made headlines around the world. On November 7, 1919, the Times of London declared, "Revolution in science, new theory of the universe, Newtonian ideas overthrown." The obscure patent clerk from Bern had become a global icon overnight. Albert Einstein, the boy who had failed his exams, had redrawn the cosmos. He spent the rest of his life as a scientific elder statesman, a humanitarian, and a tireless searcher for a unified field theory that could encapsulate all the laws of physics in a single, elegant framework. He never found it, but his quest inspired generations to come. His story is not merely one of intellectual brilliance, but a profound human drama of perseverance, imagination, and the courage to question everything. He taught us that the universe is more mysterious and more wonderful than we can ever imagine, and that the most powerful tool we have for exploring it is the boundless curiosity of the human mind. The boy who chased a beam of light had, in the end, illuminated the entire universe for the rest of us. His legacy is not just in his equations, but in the enduring inspiration to look up at the stars and wonder.